Move. Fifth definition. Work input. One minute. Huh? What do you mean by input? Means you are giving or you are taking?
Giving.
What you give? Load or you give effort?
Effort.
Effort, correct. Whatever we give is our effort. So the work done on the machine, work done on the machine, work done on the machine by effort is called as work input. Work done on the machine by effort is called as work input. The work done on machine by the effort is called as work input. Therefore, work input is equals to work done by effort. Right. Work input, work done on the machine by effort is called work input. Work done on the machine by the effort is called work input. Done. Sixth one. Work output. The work done by the machine, the work done by the machine on load. Work done by the machine on load is called as work output. Therefore, work output equals to work done on load. Work done on the load. Work done by the machine on load is called as work output. Completed fifth and sixth?
Yeah, sir.
So we did in the last lecture what are machines, therefore purpose, then load, effort, mechanical advantage, velocity ratio. Today we started with work input, work output. Seventh one, efficiency. Suppose I study 4 pages and I remember only 1 page, or I remember 2 pages. What is my efficiency?
2.
50%. I studied 4, but I remember only 2. That means input was 4, output I remember only of 2. That is called efficiency. So the ratio of work output means work done on the load. Ratio of work output to the work input is called as efficiency. It is denoted by this symbol. It is called eta. Therefore, efficiency is work output upon work input. Right. Then percentage efficiency equals to work output upon work input into 100. Out of 100 is called percentage. It has no units because it is ratio of two similar quantities that are work.
Sir, this Thursday we have our entire second chapter test, right?
Correct.
Okay, sir.
Shall I clear?
Yeah, sir.
No. The efficiency is never 100% because mechanical advantage is decreased. Mechanical advantage is decreased due to friction and weight of moving parts. That means work of input and output will never be same due to this friction and weight of moving part. Just write as a note. Next, principle of a machine. Principle of a machine. Written? Heading, principle of machine.
Yes, sir.
What is principle of moment or equilibrium? Principle of moment. Always, and sum of anti-clockwise moment is equal to clockwise moment.
Yes, sir.
But principle of machine is when energy is supplied to a machine indirectly, when input is given to the machine, when energy is supplied to a machine by applying effort, when energy is supplied to machine by applying effort, it overcomes the load by doing some useful work on it. It overcomes the load by doing some useful work on it. Not all, some useful work on it. Right. When energy is supplied to a machine by applying effort, it overcomes the load by doing some useful work on it. Yes, can I clear again this statement?
Sir, one
Sir,
minute.
you can clear the note. I'm writing the principle.
Right, no problem. The point at which energy is supplied to a machine. The point at which energy is supplied to a machine by applying effort is called as effort point. The point at which energy is supplied to a machine by applying effort is called effort point. The point where energy is obtained by overcoming the load is called load point. So this chapter is just basic one-liner definitions. Point at which energy is supplied by machine. The point where energy is obtained by overcoming load is called as load point. Completed?
Done, sir.
Yeah, sir.
Okay. See, what is meaning of ideal? हम बोलते हैं ना कोई कोई ये एकदम आइडियल है, मतलब कैसा है? उसको जो बोला वो सुनता है ना, विदाउट एनी आर्ग्यूमेंट. Suppose teacher says your exam is on Friday, please come to the class 2 hours before, we'll do revision. Practical student will not come, ideal will say okay sir ने बोला है तो जाते हैं. So suppose your final exam is on what, Thursday at 11 o'clock and I call you at 8 o'clock for revision, will you come?
Yes.
Nobody will take risk ना, 11 बजे तो अपना एग्जाम भी है. Nobody comes. Next day I give the call, I say morning 4 o'clock, please come, I have got my question paper, I have solved also, 6 o'clock I will give you printed solution. Now the students will come or they won't come?
Welcome.
They will come और बाजू वाले को भी लेके आएंगे साथ में. तो देख देख अपना सब प्रिंटेड नोट्स देने वाला है, वही एग्जाम में आएगा. तो आइडियल मतलब नो लॉस, जो बोला वो करेगा ऐसा. An ideal machine is a machine if there is no loss. So I can say an ideal machine is that in which there is no loss of energy. Hence, work input is same as work output. Work input is same as work output. Therefore, efficiency is 100%. Practically not possible. So when energy input is same as energy output or work input is same as work output, we say it is nothing but ideal machine. But actual water machine, will the output be same as input? No. In actual machine, will the output be same as input?
No, sir.
No. In actual machine, the output energy is always less than input energy. That means efficiency is always less than 100%. That is, efficiency is always less than 100%. Is always less than 100%. Right. Completed.
No, sir.
ध्यान से देखो, ये रटने वाला चैप्टर है, इधर डेफिनेशन वाला है. चलो, कैन आई क्लियर दिस?
Done, sir.
Now, sometimes they can say, what are cause of loss of energy? Why output is not same as input? So, causes of loss of energy. Suppose this is one weight and I tie it to string which is 5 kg. So I have to spend my energy to pull this also and then pull this also ना.
Yes, sir.
एक्चुअली मुझे इसको पुल करने का है लेकिन ये भी बहुत हैवी है तो इधर भी ताकत जाएगा ना.
Yes.
So I can say the strings are not perfectly elastic. That means they don't elongate. So I have to spend my energy.
Yes, sir.
So what are causes of loss of energy? First one, suppose this is pulley. ये जल्दी घूमता नहीं है तो ताकत लगा के इसको घुमाना पड़ेगा ना. तो अननेसेसरी इसको घुमाने में एनर्जी गया बिकॉज इट इज रफ, मोर फ्रिक्शन. स्मूथ रहता तो खाली इजीली पुल करके घूमता था और इधर से बॉडी लिफ्ट होता था ना ऐसा ऊपर. So if moving parts are heavy, string is heavy, then our input will not come as output. थोड़ा waste होएगा. If a student has not studied ninth, so first 15 days I have to invest to teach him ninth standard. Then only he can start understanding. So why there was loss? Because he didn't study ninth. So these are the possibility why we can lose the energy. So first cause of loss of energy is the moving parts in it. In it means in the machine are neither weightless means they are heavy nor smooth. There is some friction. Second, the strings used are not perfectly elastic. मतलब कड़क रहता है वो थोड़ा perfectly elastic. Third, its different parts are not perfectly rigid. Its different parts are not neither perfectly elastic nor perfectly rigid. These are three causes of loss of energy. Not perfectly rigid means ये थोड़ा bend होने लगता है तो पूरा input नहीं देगा. हेलो हेलो.
Yes, sir.
This meaning followed.
Yes, sir.
अभी एनर्जी लॉस हुआ है तो गया किधर, वो एक्चुअली हीट प्रोड्यूस कर देता है. So sometimes they can ask किधर गया हीट. It produces heat, energy. It produces heat in different parts. So something which is rough, if you push it तो इधर गर्म हो जाता है ना. हेलो.
Yes, sir.
सपोज अपना सोफा बहुत हैवी है, व्हेन यू पुल तो बिकॉज ऑफ हैवीनेस वी स्पेंड एनर्जी ना. लाइट अगर लकड़ी का रहता तो इजी पुल करते हैं.
Yes.
तो आपका पुलिंग के लिए एनर्जी गया 10 जूल और उसका हैवीनेस की वजह से 10 मोर जूल. मतलब एक्चुअली आपने स्पेंड किया 20 लेकिन आउटपुट खाली मिला 10. So these are causes of loss of energy. Moving part is not weightless, neither smooth. Strings are not perfectly elastic, and different parts are not perfectly rigid. Right. Will I clear it now?
Done, sir.
Okay. Now one very important relation, very important relationship between efficiency, comma mechanical advantage, comma velocity ratio. Very important. What is mechanical advantage, by the way?
Distance of effort.
No, ratio of load to effort. Ratio of load to effort, huh?
Yes, sir.
And velocity ratio is distance covered by effort to the distance covered by load, or velocity of effort upon velocity of load. Okay.
Yes, sir.
And efficiency is work output upon work input. So consider a machine which applies effort E to overcome load L. Let DE, comma DL be the displacements of effort and load in same time. Consider a machine which applies effort E to overcome load L. Let DE and DL be the displacements of effort and load in same time respectively. In same time respectively. Therefore, work input equals to effort into displacement of effort. Effort is E, displacement is dE. Work output equals to load into displacement of load. So it is equals to L into dL. Copy this much again. Once you complete, let me know. Huh?
Done, sir.
Okay. Yes, everybody has done this. Can I clear it off?
Yeah, sir.
Yes, sir.
Okay. Since efficiency denoted by eta is work output upon work input. So it will be eta equals to output is load into distance covered by load. This is effort into displacement of effort. But what is load upon effort? Can I say mechanical advantage? Load upon effort is mechanical advantage. Hello? Hello?
Yes, sir.
And effort upon load displacement is velocity ratio. So we can say eta equals to mechanical advantage L by E into dl upon de is ulta of de upon dl, means 1 upon velocity ratio. So I can say efficiency is ratio of mechanical advantage and velocity ratio, or mechanical advantage is velocity ratio into efficiency. Please copy. So mechanical advantage is product of velocity ratio and efficiency.
नरम हो जाता है रख के रख दो नहीं खाते हैं कल इससे नरम हो गया
Sir, what is that symbol of efficiency?
Eta, eta. It is called eta. Remember Nita. You remember eta. Have you remember? No, Nita Ambani.
Yes, sir.
Quite efficient. So eta. Done?
No, sir.
Not yet.
Done, sir.
Okay. Others have also done?
Yes, sir.
Okay. Now we have completed basic definitions regarding machine, load, effort, mechanical advantage, velocity ratio, work input, work output, efficiency, ideal machine, actual machine, and relation. Now some practical machines we are going to see, or simple machine. One structure I'm drawing, you have you seen this or not? Tell me. Have you seen this structure?
Yes, sir.
What is this called as?
Seesaw.
Seesaw. The point where it is fixed is called as what? Fulcrum.
Ah,
Fulcrum. What is this point called where it is fixed?
Middle.
Fulcrum. Fulcrum. That point is called as what? Fulcrum. Say what it is called?
Fulcrum.
Fulcrum. This you have seen anywhere?
Yes.
What is this called? Tongue. So with this we remove that ice cubicle or sugar cubes. They are called tongue. And fulcrum is see at the corner, not in middle. At the end it is. If this is one rod and here I lift it, so this is fixed point and here I am putting, this is fulcrum. Okay. So wherever it is fixed, it is called fulcrum. Have you seen this plucker? Mostly that mochi is having.
Yes.
This is called fulcrum. So fixed point is called which point?
Fulcrum.
Fulcrum. Now see what fulcrum is. Why we are talking about fulcrum? Very simplest. These are all our machine in the simplest form because they are giving some advantage. So now we are studying actually levers. Lever. It's not Johnny Lever. Levers. What are levers? Levers are the simplest kind of machine. Levers are simplest kind of machine used in our daily life. So simplest kind of machine used in our daily life is called lever. Now how it is defined? A lever is a rigid. Rigid means it should not bend, it should not change the shape. Scissor is a lever. The tongue is lever. Seesaw is lever. So when you sit, it does not changes the shape. Lever is a rigid, straight or bent bar. Bar means rod, which is capable of turning about a fixed axis. So lever is a rigid, straight or bent rod or bar which is capable of turning about a fixed axis. So this is that fixed axis where it can turn up, down. Lever is the rigid, straight or bent bar which is capable of turning about fixed axis. And point where that fixed axis is passing is called as fulcrum. That much you have to remember. So just write this, then I am telling what is fulcrum. Lever is simplest kind of machine used in our day-to-day life. It is rigid, straight bar which is capable of turning about fixed point, capable of turning about fixed point, capable of turning about fixed point or fixed axis. Return.
Sir, 1 minute. Done, sir.
Lever is simplest kind of machine used in daily
So
life.
just a second, I'm just writing the last line.
Whatever I am writing, explaining, 2 times will practice before you come in the next lectures. Every time. This is the rule. Otherwise, so many chapters will do, you will not remember the things. You may understand.
Yeah, sir, done.
Okay. So lever is nothing but rigid straight rod which is capable of turning about fixed axis. Fulcrum. The axis about which, axis means imaginary line, about which the lever turns. The axis about which lever turns passes through a point of the lever, which is called as fulcrum. It is denoted by F. This point does not move but remains fixed when the lever is in use. But remains fixed when the lever is in use. Right. Okay.
Done, sir.
So 1 second, I'm writing.
अरे नोरा, यू आर राइटिंग वेरी स्लो बेटा, थोड़ा फास्ट लिखो.
Sorry, sir.
Hardly 2 lines to write, so much time.
Done, sir.
Okay. There are three types of lever. First, class 1 lever. Second, class 2 lever. Third, class 3 lever. I have remembered like this. Flea. Class 1 F is center, class 2 L is center, class 3 E is center. Remembered as flea. This is class 1, class 2, class 3. F at center, load at center, effort at center. There are three types of lever. Just write this, then I will draw the diagram of this meaning of class. All the three types. FLE, remember, F center, it is class 1. L center, class 2. E center, class 3. Remember as flea. FLE, flea. 1, 2, 3, flea. Means fly. 1, 2, 3. Return. Can I explain with diagram now?
Sir, 1 minute.
Yes, sir.
How to remember? FLE. Like we said, 1, 2, 3 move. So flea. First is first class, second class, third class. F center first, L center second, E center third. So diagram we are drawing of all the three. First one, second one, third one. At center we have F. Center means not necessarily exactly at the center, in between. This is fulcrum. That means fixed point about which this lever will move. F. Now load and effort you can put anywhere. So if this is effort and this is load, A and B are end points of that lever. Anywhere in between we have got F. Distance from effort to the fulcrum is called as effort arm. This is effort arm. And load to fulcrum is called load arm. This first one is class 1 lever. Second, class 2 lever. Generally we represent by Roman letters. Just draw the diagram of class 1.
Done, sir.
Now F L E. L is load, is effort. Fulcrum at the end. Fulcrum at the end. F, F, this is load, this is effort. In between effort, this is load. Point A, hello, hello.
Yes, sir.
At A we are having effort, and here B we are having load. Then A we are having effort, B we are having load, F is fulcrum. All the three diagrammatically followed.
Yes, sir.
Can I say here this load and effort arm can be either equal or less or greater? But here A to F is effort arm, always greater than load arm because this distance is more. Just draw the diagram first. Just draw the diagram, don't get confused. How many types of lever are there? Three. F, L, E. F center class 1, L center class 2, L E center class 3. F, L, E.
Done, sir.
Principle of lever. It works on the principle of moment. What is principle of moment? Yes, what is principle of moment? At equilibrium, anti-clockwise moment is equal to clockwise moment. Hello?
Yes, sir.
So here also it is same. It works on principle of moment. According to which at equilibrium of lever the clockwise moment of load about fulcrum must be same as anti-clockwise moment of effort about fulcrum. Hello, followed?
Yes, sir.
Clockwise
Yes,
moment
sir.
of load about fulcrum must be same as anti-clockwise moment of effort about fulcrum. Yes, please write this. Chalo, can I clear it?
Sir, 1 minute.
Okay.
Done, sir.
Okay. So it works on the principle of moment according to which at equilibrium of lever, clockwise moment of load must be equal to anti-clockwise moment of effort at fulcrum. So that means load into distance of load is called load arm. This is force into distance. That means load into load arm equals to effort into effort arm. Any doubt in this line?
No, sir.
If this is fulcrum, this is load, then load into this distance or force into this distance is called moment. So load L into load arm, load we are putting at B. So from the diagram it is FB equals to effort E, effort is put at A, that is F to A distance. So load upon effort is FA upon FB. What is load upon effort called as? Is it mechanical advantage?
Yes, sir.
Okay. So we can say that is, therefore mechanical advantage equals to FA. FA means effort arm upon load arm. So like velocity ratio जैसा हो गया ना थोड़ा, effort arm to load arm.
Yes, sir.
So mechanical advantage load upon effort is effort arm upon load arm. This relation means mechanical advantage is effort upon load arm. This relation is known as law of levers. Write this much. Then we will state law of lever.
Done, sir.
Yes, Yes, you all have done that? Hello, everybody had done?
Yes, sir.
Okay. Thus, mechanical advantage of lever is defined as the ratio of length of effort arm to the length of load arm. Therefore, first point, if effort arm is equals to load arm, mechanical advantage will be 1. Second, if effort arm is in numerator is greater than load arm, then mechanical advantage will be greater than 1. If effort arm is less than load arm, mechanical advantage less than 1. Right, these 3 points.
Sir,
Yes,
sir, what is this line? Means this word.
first line, second line, third line. Okay,
Sir, this marked.
length. Sorry, actually my handwriting is good, but with this pad it is not coming. Length. Ratio of length of effort arm to the length of load arm. Followed now. Length it is length.
Yes, sir.
Okay. Saksham, can you tell how to change this length of load arm or effort arm by moving it away from fulcrum? Because you are measuring from fulcrum. fulcrum से दूर गया डिस्टेंस बढ़ेगा, fulcrum के पास आएगा डिस्टेंस कम हो जाएगा. Completed?
Yes.
Okay. So today we'll stop here. Please revise and be ready. Thursday we will have test on entire second chapter, and again Sunday lecture same